Oh, bro. I didn't know.
We ready? All right, so let's talk about what we've learned so far. Actually, I might just drop into the notes. That was just going to give you guys an idea. Okay, so things I want you guys to keep in mind with this question, because it is going to affect if you're able to get an excellence or not. The terminology of molecule, you are only applying to the covalently bonded things that are small. You are not using it to describe ions. You're not using it to describe metals. You are not using it to describe covalent networks. You only use it in that terminology. So just be careful when you're writing, because I see this a lot happening. You guys use the word molecule interchangeably with particle or ion, and it will prevent you from getting excellence because you need to know your vocabulary. And I know I do slip into it every so often, and then I try to correct myself so that way you guys don't pick up bad habits. Cool. So we are talking about these molecules and whether these molecules are going to be polar or non-polar. The best way I like to think about it is as a flow chart, and how we're going step by step to go, oh, it's going to do this, yes or no. So when we talk about something being non-polar, we're talking about a molecule that has an equal distribution of charge or no charge. If we're talking about a substance that is polar, we're talking about an unequal distribution of charge. And so we have something that's slightly negative and slightly positive. Are we okay with that? Do you want me to write that down? Yes? Okay. So when we talk about something being polar, it has an unequal distribution of positive and negative charge. So, for example, if I look at the water molecule, H2O, we see that the oxygen end is going to be slightly negative and the hydrogen end is going to be slightly positive. So that's an example of a polar molecule. A non-polar molecule has an equal distribution of charge. So that means that it doesn't have any slight negative or slight positive ends. Or if it does, it cancels out. So for example, we could have something like the chlorine molecule. Both of these are the same thing, so they're going to share those electrons evenly, and so it's going to have no charge. Another example could be methane, which in this case, the carbon is slightly more electronegative than the hydrogen, so it is going to pull it a little bit closer, like that. But everywhere around the molecule is going to be slightly positive, and so that's the same charges over all around it, so it cancels out. So that cancels out with that one cancels out with that. So again, non-polar molecule, because those charges are canceling out, and because they're all positive. So all positive charges, they're canceling out against each other. This one here is positive and negative, and so they're different, so they're not canceling out. I'll explain this again some more when I go through my flow chart. Okay, so if that doesn't make sense, we'll go through the flow chart. All right, the first thing that is required when we're asking whether or not a molecule is polar, move my thing over there. The first thing we need to ask is there a polar bond? So that's so when we're trying to decide polarity of molecules, question number 1 is there a polar bond? So again, we have to be careful in chemistry because we're going to use the word polar in 2 different contexts. We're going to use the word polar in context to the bond, and we're also going to use the word polar in context to the molecule. So just watch out for that. The way that I'm kind of explaining it is how you would scaffold your answer on the exam. So the first thing is there bond. The way we decide that is the electronegativity. Make sure when you are doing that answer, you define what electronegativity is, and you also use the examples of the atoms that are involved in that bond. Okay? So that's the first thing we got to ask. So it goes basically down to a yes or no. Yes, it does. No, it doesn't. So for example, an example of a no is the chlorine. That's going to be a nonpolar bond because that's going to share its electrons evenly. If the answer is no, you automatically have a nonpolar molecule. The first step we need to have is an unequal sharing of electrons, an unequal distribution of charge. So if it's no, you're automatically nonpolar. If the answer is yes, then we have another question to ask. The next question we have to ask, if the answer is yes, is there symmetry in that molecule? So yes, say for example, you have oxygen and hydrogen, or you have carbon and hydrogen. In this case, the oxygen is more electronegative than the hydrogen, so it's going to pull those electrons closer to it, making this slightly negative and that slightly positive. Again, in this case, for the carbon and the hydrogen, it's going to pull the electrons closer to the carbon. And then we do a little bit of another dash there, so that way it shows positive. So again, that's slightly negative, that's slightly positive. So make sure whatever question you are doing, you are pulling it apart and going, these are the two bonds, and whether or not that's going to result in a polar bond based on electronegativity. The next question we ask is there symmetry in the molecule? If the answer is yes, then again, we have a nonpolar molecule. And the reason why is because the charges are canceling out. Just watching our time. So for example, if I had the butane molecule, yes, there are polar bonds present because the carbon and the hydrogen are not sharing the electrons evenly. However, the molecule itself is symmetrical. It has exactly the same thing all around it. So that's slightly positive, that's slightly positive, that's slightly positive, that's slightly positive. So all of that's going to cancel out. And so overall, this is a nonpolar molecule. So there's two factors that we got to think about. If the answer is no, then you have a polar molecule. Are we okay with that? I'll show you guys some exam questions so you can see how it's applied. Okay, doke. So polar bonds doesn't necessarily mean polar molecule. It depends on the symmetry as well. But if you have a nonpolar bond, then you automatically have a nonpolar molecule because there's no unequal distribution of charge. All right? So that's why I'm saying it's a two-step question. And if you organize your answer that way, you'll be able to get an excellence. If you jump ahead and let's say you just go straight to the molecule and you forget about explaining the electronegativity, you'll be limited to a merit because you've only talked about symmetry then. All right, let me show you guys some exam questions just so you know what it's looking like. Let me find my open. Structure and bonding. The other thing I want us to think about is lone pairs of electrons because it does affect it too. Polarity. There we go. Just so you guys can see what the questions look like. So you see how in this one they've given you two molecules. This one is not symmetrical. This one is symmetrical. So both of these have polar bonds. In fact, you're most likely going to get things that have polar bonds because statistically speaking, it's very unlikely you're going to have something that's greater than or less than 0.4. Even though these are all like the chlorine and the fluorine are both more electronegative than the carbon, they're different amounts of electronegativity. So this fluorine here is more electronegative than the chlorine. So between the carbon and the fluorine, this is going to be negative, that's going to be negative, that's going to be negative, and that's going to be negative. However, this is going to be slightly more negative than these three. So that means unequal distribution. This here is going to be a polar molecule. This one here has symmetry. All four of these are chlorines. So there's a polar bond there, but there's symmetry. It's going to cancel. That's going to be nonpolar. When it comes to these questions, they are very likely to give you a polar and nonpolar because they want you to be able to compare and contrast. The other nice thing is they give you something like this, which is essentially a multi-choice question, and that's an achieve point. So take a guess when you are having these molecules. Take a guess when they give you information about shape, because a lot of it is like if you guess it correctly, then you haven't achieved. This one here, again, something else to think about. You see how you have a lone pair of electrons here. Again, that negativity is going to be different than a slight negativity from the chlorine. So this is, again, another another polar molecule because it doesn't have the same type of negativity, whereas this one does have even negativity, so it will cancel out.
So that's non-polar.
So that one's polar. All right, and that's basically what you're looking at. Sometimes they do weird things like this, where they give you stand-in letters, but the concepts are still the same. All right? Questions, concerns, or comments about that? All right, cool. I'm going to stop it here, and I'm going to go through the last bit of notes, which is about our covalent networks. Yes, okay.